Welcome, and thank you for your interest in the Precision Digital Pitch Gauge. This gauge is the latest in a series of devices developed by Precision Analytical Instruments designed to make bowling pro shops more accurate and more efficient. The ability to precisely reproduce a bowler's existing grip is an essential pro shop function, so the ability to accurately measure the diameter and pitch of each gripping hole is also essential. The Precision Digital Pitch Gauge employs a unique new approach, simultaneously displaying diameter and pitch measurements to the nearest 1,000th of an inch. The gauge measures up to an inch of pitch and diameters from 1/2 inch to 1.5 inch, the larger diameter being useful for interchangeable grips. The gauge is especially handy for measuring ovals, since it not only measures the dimensions but also the oval pitch and oval angle. The Precision Digital Pitch Gauge and our other quality bowling products are distributed by Jayhawk Bowling Supply. For more information concerning the Precision Digital Pitch Gauge, including a downloadable manual, please visit www.toolsforanalysis.com. First, we'll describe the features of the Precision Digital Pitch Gauge, briefly review what hole pitch is, and explain how the gauge works. The gauge uses a single 9-volt battery, and power is applied with a toggle on, toggle off button. To preserve battery life, the gauge automatically sleeps after about 90 seconds. A good quality battery should last for several months of use, and when the battery is spent and should no longer be used, the low battery indicator light will illuminate. It only takes a moment to install or replace the battery. The gauge displays hole diameter and hole pitch to the nearest 1,000th of an inch, and a conversion chart is conveniently placed on the front of the device for finding fractional values to the nearest 1/32nd of an inch. The gauge features stainless steel fingers with precision stainless steel bearing movement to ensure many years of accurate performance under typical pro shop conditions. The gauge ring rests on the surface of the ball and is constructed of anodized aluminum. The hinge permits the gauge to lean forward and backward in a given hole so that the pitch along a particular axis can be measured independently. In addition to displaying the angle at which an oval was cut, the degree of oval scale also provides marks for aligning the gauge to the pitch plane parallel to the grip center line. Finally, the finger tabs located on the back of the gauge make it easy to insert and remove the gauge's fingers from a given hole. The Precision Digital Pitch Gauge measures pitch differently than other gauges on the market. To understand how the gauge measures pitch, let's first review what pitch is. If a hole is drilled such that the bit is aligned with the center of the ball, then the hole has 0 pitch and enters the ball perpendicular to the surface of the ball. Note that for a round hole, the diameter does not affect the pitch of the hole. If the bit is aligned to the right of center, then the hole has right side pitch, which the gauge displays as a positive value in inches. If the bit is aligned to the left of center, then the hole has left side pitch, which the gauge displays as a negative value in inches. If the bit is aligned forward or reverse of center, then the terminology depends upon whether you are drilling finger or thumb holes. The standard convention uses the center of the grip as the reference point, where reverse pitch is given when the bit is moved away from the center of the grip, and forward pitch is given when the bit is moved toward the center of the grip. Whether the gauge displays a positive or negative forward or reverse pitch value for a given hole will depend upon how the operator orients the gauge relative to the grip. Although it is true that a drilled hole with non-zero pitch does enter the ball at an angle, it is important to remember that pitch is defined as the distance from the center of the ball, and not as an angle. So, how does the Precision Digital Pitch Gauge work? Simply put, it simulates the drill bit in a mill. The fingers of the gauge enter the ball just as the drill bit would. The fingers automatically expand in the hole, and the distance between them is used to calculate the hole size, which is displayed in inches on the hole diameter display. If the hole is offset from the center of the ball, in other words it has side pitch, then the fingers move sideways to align to the hole, and their average position offset from the center of the ball is displayed in inches on the pitch display. Note that the body of the gauge is stationary and is aligned to the center of the ball, like the ball jig, whereas the fingers of the gauge align to the hole, simulating the drill bit. The gauge can measure diameters from 1/2 inch to over 1.5 inches, and side pitches equal to plus or minus 1 inch. Although it can't measure all pitches at all diameters, as shown in the chart, it should be suitable for nearly all pro shop situations. Now, we'll demonstrate how to use the gauge to measure round holes. In situations where the pitch does not need to be known to better than 1/16 of an inch, you can simply insert the gauge, line it up approximately, and read the values. However, when a more accurate pitch measurement is desired, you will need to align the gauge more carefully to the grip center line. To help with this alignment, we recommend that you draw the grip center line well beyond each side of the hole to be measured. Then, after inserting the gauge, carefully align the gauge so the alignment marks are parallel to the drawn center line. For a hole with 0 pitch, the alignment marks will align directly over the grip center line. But for a hole with pitch, the alignment marks should be offset but parallel to the grip center line. When the drilled holes are perfectly cylindrical, the gauge practically aligns itself, but in cases where the holes are heavily beveled, we recommend that you gently rock the gauge back and forth to find the position that gives the maximum diameter before reading the pitch. Make sure that the gauge is firmly seated on the ball and that the fingers are fully engaged in the hole as well. Think about this for a second. If the bowler is using a bevel knife to change the shape of the hole, they are also likely changing the average pitch of the hole. Finding the pitch where the diameter is at its maximum allows you to find a new and potentially better fit for your customer. Finally, we'll demonstrate how to use the gauge to measure oval holes. A detailed discussion is also included in the downloadable manual, including a step-by-step worksheet. Using the approach employed on the worksheet allows you to obtain the oval parameters to a tiny fraction of an inch. Measuring ovals can be tricky regardless of which tools you use, but with common sense, a little detective work, and some simple math, you should be able to precisely determine the parameters of most ovals. The Precision Digital Pitch Gauge has features that make this detective work fast and accurate. Why not just use the gauge to measure the pitch of an oval hole and be done with it? This approach actually makes sense in some cases, but it depends how accurate you want to be. Remember, unless you expand a hole symmetrically from the original hole, you are also changing the pitch of that hole in at least one direction, often two. The amount the pitch changes depends upon the degree of oval and the oval length. The pitch can change up to 1/2 the oval length, so the pitch of a 90 thousandths oval could measure up to 45 thousandths different than the pitch that was originally used to drill the oval. The largest change is, of course, along the oval's long axis. Thus, for small oval lengths, or in cases where an approximate value may be close enough, you can just use the value displayed on the gauge. However, if you want to be more precise, you need to do a bit of simple math. There are 5 things you need to know to duplicate an oval: what drill bit size to use, how far to move the drill bit, where and how to drill the first hole, and along which angle to move the bit. All 5 of these oval parameters are easily obtained by first measuring the oval along 2 directions and then performing some simple calculations. The worksheet helps you to organize your work, and the math is simple enough that you will probably not need a calculator.